Good afternoon. I'm going to show you the technology used beyond the Azure IoT simulator. That's a product, and I thought that when you ship a computer to load data for the customer, you would like to know where is your computer, where are the hundreds of terabytes of data of your customer. So that's why I built the product around IoT, and in particular, I thought of using the Raspberry-Pi online simulator, Raspberry being a nice tool to simulate. The project takes two resources: a DataBox hub with its own devices, which is here, and another one is a DataBox storage with a blog account with a DataBox payload container which contains nothing. Now let's go see the on the development side. The solution is based on the three projects. We got like a console, the emulator, and the geo-tracking. The console is basically Node.JS with like a server which like contains its own what they call middleware, and all the logic is made in routing, where it's where you decide to put values and it's interpreted, and you have like views which are here, and it does handle all the form upload, and this is in particular send command to the device manager through IoT. The Raspberry, which is a native React project, use libraries. The libraries are created like, whereas this library which is like given, which is like basically a thermometer. So I created a geopositioning library, which is here, which give you the latitude and longitude, and this is the code, and you can see that I'm going straight on the line from A to B. You can see like that some word syntax, and it's because when you read the data, you return what they call a promise object. A promise object is not the result, but a hook for a function to read the result. And that's why you have a very strange syntax when you go to check the certitude, is that when you read the data, you don't just stop there, you don't put a colon to say this is my value. No, you call a lambda function where you pass a parameter. That lambda function is going to be called like asynchronously, and then you treat the result. So it's kind of like difficult to understand the beginning why they put those then. And same way, when you download the file, you want the result, and you have to insert that, otherwise it doesn't work. The last piece software is the geo-tracking, and the geo-tracking is based on Gmaps, which is a very nice library given by Google. The Azure geopositioning wasn't that flexible, and we have like a system of view with like here we say inside the body, which is like what they call their system of active page, GSP, and that body is replaced by that second view, and the values latitude longitude are given here is where you do the mapping in your code, which is like there when you associate values to your code. So let's start the project. First, we need to start the console. then our simulator, then our geo-tracking. As you can see, when you start the simulator, automatically it spawns on your VM your data. And we have like here, where is it? A web server which is running, but to give access to the page, icon, kind of things. Let's do the demo. So, have access here. Simulator. And you can see the beginning, the geo-tracking of our DataBox is in Paris shows that we didn't start the simulator, which is all good. We run it and it's going to move quickly to Montreal. And here we go. I put an auto refresh on that screen. So let's order the DataBox. On the order DataBox, you have a message that is sent through IOT, which are received here, and you can see the result. Now let's ship it. So when you do that, it starts to blink to see that it's moving, and the blinking is in the code there. And you can see it moving on the screen. And blinking is, where is it? Here it is. That's a code to blink with the head. And it's moving. You can see the different latitude given by the simulator, which is received by sent by our simulator, received by our map. So the map is following a simulator through Montreal, flying over the island, going straight to the head office, and when we finish, we know there because it stopped blinking. Let's upload a file. You can see the file is being sent through IoT to the simulator, recorded, and SD card, the simulated SD card on the simulator is still there. Now we return the DataBox to the head office, and you can see there it's start to come back. Here we go. Should be able to see the code doing that. Where are you? Here it is. You read the data. Again, that's the word syntax. In the latitude, it says like if you're like an Azure NAT, and when it's traveling, it blink. So that's why you got a blink there. It just stops being that it arrived at time, and you can see that here is back at Azure, and the status means back at the office. So now we can upload the data. Here we go. And the way I had to do it is because React Native doesn't support access to the Azure Data Store. So I have to send a message from here to say, give an order. We read the SD disk and send another message, a payload, to that geo-tracker. We're going to see that a bit further. And there you receive the message. So let's check now the end result. So we should have a file. Yes. Cool. Let's check it. Ah, here it is. That's my son making drawings. Thank you very much, and for watching.